Thank you for the question you sent me from section 11.3. That's section 3 in our statistics chapter. It's this question about expected value. And expected value is a new topic for many students. After you've practiced it a number of times, it might fall into a nice, easy rhythm for you. So I'm going to try to explain this problem in such a way that you can pick up on the pattern and then apply this to any expected value problem. And here's how it goes. This is a shorter example because there are only two different possible outcomes. We either have rain or we have it not rain, so dry. And so it makes it a little easier than some of the expected value problems. But you could do this with multiple steps also. There could, if it was something like rolling a 1 or a 2 or a 3 or a 4 or so on. So there could be 6 different possibilities instead of only 2. But let me walk you through this one. I'm starting the problem by really understanding the problem. And for me to understand the problem, I take notes like what you see up here in the top. I've written down that the probability for rain is 80%, so that's 0.8. And if it does rain, we can expect 7,000 people to attend. The problem doesn't ever say that the chance of dryness or the chance of not raining is 20%, but I can deduct that because 100%, we have a 100% chance that there's going to be either rain or not have rain. And so if I do 100 minus that 80%, I'm left with that there must be a 20% chance of it not raining because those probabilities have to add up to a perfect one. 0.8 plus 0.2 adds up to 1.0 or 100%. So if it's dry, I know that there will be 10,000 people attending. So on the day of the concert, jumping to the last part, I'm reading at the wrong place. Determine the expected number of people who will attend the concert. The expectation for attendance is going to equal the probability of rain times how many people we could expect to attend if it rains, or in other words, the probability of the first event happening times the outcome of that first event. If we translated this over to a lottery game, it would be the chance of winning times how much you win. But in this case, it's the chance of rain and then what attendance we expect. And then the next possibility is if it's dry. So we'd have a 20% chance of dry or not raining times the 10,000, and that gives us a 2,000. If we add these two values together, we get our completed answer. Our expectation for attendance is that we could expect 7,600 people. Now, does that mean that 7,600 people are going to attend? No, it doesn't, because it's if it rains, we're probably going to have fewer. If it rains, we're going to have fewer. If it doesn't rain, we're probably going to have more. But what we're going to plan for this event is 7,600 people. That's what this expectation does for us. I hope that this helps with this problem, and I will try a few more examples, so please let me know if there's a particular part of this problem that doesn't make complete sense to you. And keep up the great work.